Today we're going to look at at analyzing square root functions. The square root function, parent function specifically, looks a little bit different than the other parent graphs. And what I mean by that is instead of it kind of being centered at 0, 0 and going off in both directions, this graph starts at 0, 0 and then only goes off to the right. So for my table, I'm going to start at 0 and I'm going to go up to 4. Now to complete our table, I have to take the square root of each of my x values. So the square root of 0 is 0. The square root of 1 is 1. The square root of 2, if you put this into your calculator, gives you a really long decimal. I'm going to round it to 1.4. The square root of 3, again, I'm going to round to 1.7. And the square root of 4 is 2. So the way I'm going to plot my points here, here's 0, 0, 1, 1, 2, 1.4, 3, 1.7, and 4, 2. So this is what our square root parent function graph looks like. The domain of this is not all real numbers like almost all the rest of them have been. The domain is everything greater than or equal to 0. And I want to point out this point right here. It's 0, 0. This is what I'm going to call our starting point. It's where the graph starts and then it goes off to the right forever and ever. Your domain and range numbers will always come from these, from this starting point. So my range is also going to use 0. And since my graph is going up, that means that all of my y values are going up. That means they're going to be all greater than or equal to 0. Now end behavior, you'll notice that there's only one arrow. And what that means is that we're only going to have one end behavior statement. So I'm going to cross off the second line here. We're always going to be talking about as x goes to infinity. So as x goes to the right, because all of our graphs are going to start and then go to the right. So as x goes to infinity, my y value is going up, and that's the only end behavior statement that we need. I want to write down our kind of our formula that we've been using, but I'll make it specific to the square root function. So all of these letters, A, H, and K, behave the exact same way regardless of what family it is. So when I see for number 1, I see that there's a negative in front of the radical. That tells me that this graph is being reflected. The -6 that's inside the radical is telling me that's the h value. That's a horizontal shift, and you have to do the opposite of what it looks like. So this is going to the right 6. And then this 4 out here is our k value, and that keeps the same sign. So that is shifting the graph up 4. For number 2, the first thing I see after the equal sign is 1/2. That's my a value. And because it's less than 1, that means that this graph will have a vertical shrink of 1/2. And then the only other thing here is this 5 that's inside the radical. That tells me it's my h value. And since I have to do the opposite, it's telling me that this graph is going left 5. The first thing you always want to identify on these graphs is the starting point. So I see right here, this is my starting point, and it's at the point 2, 4. So it tells me a lot of things. It's going to help me with my transformations. It's also going to help me with my domain and range. But before we get there, I want to look at the a value. So remember that you start at your starting point. In the past, we've started at the vertex or the point of inflection. Whatever that standout point is, you always go right 1 box, and then you count however many boxes you have to go up or down until you get to the graph. So in this graph, we had to go up 1 box, so our a is 1. Now when your a is 1, it's not being reflected, and 1 is the standard that goes with the parent function, so we don't have to say that it was stretched or shrunk because it's neither. It's just exactly as wide or narrow as the parent function. So as far as my transformations go, I want to write that I have, I'm going right 2, and I'm going up 4. And that's all that's happening. I don't need to write anything about the a value. My equation, I don't need an a number, So I can go straight to my square root. Since I'm going right 2, I want to use x minus 2. And then up 4 would be plus 4. Now for my domain and range, I was talking about this point right here that I'm putting a star next to, that point being used for domain and range. Since this point is an x and a y, my x values go with domain and my y value goes with range. Now your x value will always match the arrow of your graph here. So since this graph is pointing to the right, I want greater than or equal to. The range can change, and it's depending on whether or not the graph is reflected. So since this graph is not reflected, that means it goes up. That means that my y is going to always be greater than or equal to 4. And to kind of get a visual of what I'm talking about here, I'm going to find the coordinates of this green point here, which are 3, 5. If you compare the x value of 2 and the x value of 3, so my start point is 2. That's why I use 2 in my domain here. And that number, if you look at what it is when you do the a value, the number is 3. That number is greater than 2. So I want my sign to be greater than. And then same thing with my y value. It starts at 4 and the next value is a 5. 5 is greater than 4, so I want a greater than sign. Now my end behavior is the last thing. Our x's will always be going towards infinity. And then this graph is also going up, so I want my y to go towards infinity. And remember that we only have one end behavior statement because this graph has one arrow. It only goes off forever and ever in one direction. For number 2, my start point is the point 1, 2. So that tells me that I'm moving the graph right 1 and up 2. And then I also need to identify my a value. So I'm going to go right 1 box, and then I have to go down 2 boxes to get to my point. So my a value is -2. So that tells me I have 4 transformations. This graph is reflected because the a value was negative. I also have a vertical stretch because the value of a is 2, which is bigger than 1. And then I'm also going right 1 and up 2. So as for my equation, my a value goes first, -2. Then I have my radical with my x and h, so that would be x minus 1. And then I would have plus 2. As far as domain and range go, remember that I'm going to be using my point here, my starting point. So I'm going to be using x and 1, y and 2. My x value, or my domain will always use the inequality sign that matches the arrow. So this arrow is pointing to the right. And then my range value, since this graph is reflected, is going to be opposite from question 1. So another way to see that, like we talked about before, this is now the point 2, 0 if I look at my green point that I used to find a. If you look at your original x value, so your starting x value was 1, and then the next point over is 2. 2 is greater than 1, so I'm going to use a greater than sign. For my y values, my start value is 2, and my next value is 0. 0 is less than 2, so I'm going to use a less than sign. And then end behavior, remember that we're always going to the right towards positive infinity, and now my y values are getting lower, so that are going towards negative infinity. We want to first find our start value, and that point is at -3, 0. So that tells me that this graph got shifted left 3, and it did not shift up or down. Now I want to find my a value, so I'm going to go right 1, and I have to go up 2 to get to my point, and I'm going to actually label this point now, which is -2, +2. So this tells me that my a value is +2. So now I can write my transformations. So I would have that it is a vertical stretch because my a value is 2, which is bigger than 1. It also shifted left 3. And that's it. It's not being reflected, and I don't have a vertical shift because my start point has a y value of 0. So the equation is going to look like this. I'm going to write my a value first, which is 2. And then under the radical, I have x plus 3 because it's going left 3. And then I don't have a k value because it's 0. For domain and range, I'm going to write down my x and y value of my start point, and that's the blue point. I know I have 2 points up there, but I want to use the blue one. So my domain number I'm going to use is -3. My range number is 0. So my x, or my domain, will always use the same arrow as the graph, so that's greater than or equal to. And then my range value, if I take a look at my numbers here, my start value is at 0 and I end at 2. 2 is greater than 0, so I want greater than or equal to. And then for my end behavior, as x goes towards infinity, my y values are going up, so they're also going towards infinity. To identify domain and range, we're going to use that standard formula again. So I'm going to write it out. And what we're going to do is we're going to use the h and k values. In the past, we've used those to find the point of inflection or the vertex, depending on what the family is. But now I'm going to use it to find my starting point. But we're going to do the exact same thing. It's not going to change anything. We're just calling it something different. So the starting point is going to be hk. So remember that your h value needs to change signs if you have one other than 0. So let's go through and figure out the starting points. So the starting point for number 1, there's no k value, so I'm going to add a +0 so you can see it. So the starting point here would be 2, 0. The starting point for number 2, there's no h number, so that means the h number is 0, and then my k is 4. And then for number 3, I would have -1, -5. So I change the sign of the 1 and I keep the sign of the 5. At this point, once you have these numbers, now you can do things pretty much exactly like we were doing in the previous slides. We were taking the starting point. I would say that, for domain and range, we would have that the x goes with the 2 and the y goes with the 0. And now, instead of being able to see if the graph is reflected or not, you're going to have to use whether or not it has a negative for your a value. So if your graph is not reflected, both of your signs are going to be greater than or equal to. So if you look here, number 1, there's no negative sign here, so I know both of my domain and ranges are going to be greater than or equal to. For number 2, I know that I'm going to use x and 0, y and 4. This graph is also not reflected, so both of my signs will be greater than or equal to. For number 3, x goes with -1 and y goes with -5. This graph is reflected, so my x value will still stay greater than or equal to, but my y value will switch. So I'm going to write down here at the bottom just a little shortcut. So if graph is not reflected, domain and range will both be greater. Oops, this should be an x. Let me start over. X will be greater than or equal to, y will be greater than or equal to. If graph is reflected, so that means that you have a negative in front. The first thing you see after your equal sign is a negative. If it is reflected, your domain will still be greater than or equal to, but your range is going to be less than or equal to. And then, again, I didn't write this down, but it would be greater than or equal to h, greater than or equal to k, greater than or equal to h, less than or equal to k.